So let's solve using the formula method. And whenever we're solving, we're going to use the three-step approach. So the three-step approach is: one, we're going to convert if we need to convert. Two, we're going to think about the process, think about our outcome, make sure we have the units that we're needing. And three, we're going to calculate. And I always like to add one more think to it. At the end, we want to make sure, does this make sense? Is this our outcome that we were looking for? And is this a safe outcome? So I'm adding think to the last step here. Of course, that's it's the second step in the three-step approach, but it doesn't hurt to make sure and this is correct and always clarify. All right, so let's go back and solve this using the formula method. Well, when we talk about the formula method, we're talking about desired over half times quantity. Okay, so what is D? D is going to be our order. It's what we desired. You know, it's what is told that we need to solve for or give, administer, or whatever it may be. H and Q is going to be what we have available to work with. So we got the order placed from the doctor or the nurse practitioner. Then we go to the pharmacy or the cabinet or whatever it is that you have access to in the field of study that you're working in. And the H and Q is what we have on hand. So my H is going to represent the strength of whatever we're working with. And Q is going to work with the dosage, quantity. Okay, so now let's solve for this one here. So we're going to start off with the three-step approach. The first one says convert if we need to. Well, I'm going to look at it. I have this order here, and it's 150 micrograms intramuscular stat. And then when we look at the supply, what do we see here? The supply says that we have 0.2 milligrams per milliliter. So yes, we're going to do step one. And how come I know this is because we need these two right here. We need our D and our H to reduce. And in order for it to reduce, the units need to be the same. The numbers is not always going to be the same, but the units be the same. Our goal, our quantity we're solving for is going to be our milliliters here. So let's talk about our relationship between micrograms and milligrams. We know for every 1 milligram, it equals 1,000 micrograms. So this means that we're either going to convert the order to milligrams or we're going to convert the supply to micrograms. Whichever option is going to be a correct outcome as long as your math is correct and you're using the correct needed conversion. Everybody will have their own outlook on it. I see that this right here, the milligrams, has got a 1 coefficient in front of it. So that means if I convert the milligrams to micrograms, I'm only dividing by 1. So that's my option. However, you can do either one. You can solve for the order or the spot. So what I'm going to do is clean up the order. I'm going to take the 0.2 milligrams out of the order, and then I am going to take my needed conversion. And in this case, this is going to be my have, and this is going to be my Q. I did say Q is our dosage, right? And our have is our strength. But when we are doing the needed conversion, if you notice, they're both strengths. Okay. So how do I know which one's have? Have is going to be the one that's going to reduce with the one we're trying to undo. So this is my have. So I'm going to divide by 1 milligram. I'm going to multiply that by 1,000 micrograms. And what do I have? Well, 0.2 times 1,000. There's 3 zeros. It means I'm going to move the decimal over 3 places to the right. It gives me 200 micrograms. Okay, good deal. So now what I'm going to do is just make me a little side note here and rewrite it. I got 200 micrograms per milliliter. So if you need to, it's a little messy. Kind of section this off a little bit. Now let's do our formula method. Our desired is our order, which is 150 micrograms. My have came from the supply, and it's going to be the strength, which is 200 micrograms. And look, guys, what happened? We actually are able to reduce the micrograms, right? They go into each other one and leaves me with one. So I set that up right. Now I'm going to multiply it by the quantity, which is 1 milliliter. And now let's divide this out. 150 divided by 200 gives me 0.75, and then it's milliliters. And that is my answer using the formula method and the three-step approach.